Let's talk about dividing monomials. First, I'll begin by multiplying monomials with the law of exponent. Um, did not introduce that before for multiplying monomials, and please excuse me for that. Um, Forget putting the horse before the buggy or something like that, or the buggy before the horse. I don't know, but anyway, um, when we're multiplying monomials, if they have the same variable, the same base, where here x is said to be the base, and then that's x there as well, and then m and n are called exponents. If you're multiplying two variables, they have the same base, then you simply add, you see that? You add the exponents. Keep the common base, x, raised to the n plus m. So we kind of did this in the previous section, but x to the fifth times x to the fourth is x to the ninth, right? Five x to the third times 4x to the seventh. I'm going to say multiply. 5 times 4 is 20. And then we have x to the third times x to the seventh. This is 20 times x to the 3 plus 7, because they have the same base. X is the base, right? So if you have that, you're multiplying numbers, they have the same base. Keep the common base, add the exponents. Well, now, in terms of dividing, if you have x to the n all over x to the m, then this is just x to the n minus m. For example, if we have x to the fifth all over x to the second, that's x to the 5 minus 2, or x to the third. Now you think about that, and it should make sense that this is x times x times x times x times x. Should be 5. 1, 2, 3, 4, 5. Divided by x times x. If I use the law of cancellation, x divided by x cancels out, x divided by x cancels out. How many do you have left? How many x do you have left? 3 of them. It's not 3 times x. This is x times x times x. This is x to the third. Okay. One more example, then we'll look at the exercise in Plato. So if you have negative, let's say 81. Oh, no, let me do this. Let's make it interesting. Negative 81 x to the 6th, y to the 8th, z to the 2nd. That's over 9 times x to the 3rd, y to the 5th, divided by z. That's good. Now I'm going to deal with each term that are alike. Each term that is alike is r. Okay. So anyway, negative 81 divided by 9. Well, 81 divided by 9 is just 9, so it's negative, right? Because negative divided by positive is negative. And look at the x's. Deal with those. They're like terms. X to the 6th divided by x to the 3rd. Same base. Becomes x to the 6 minus 3. That's 3. Then y, this is y to the 8th divided by y to the 5th. This is 8 minus 5, that's y to the 3rd. And then this is z to the 2nd divided by z to the 1st, that's z to the 2 minus 1. That's just z to the 1st power, or you can just write that as z. And don't even worry about that because that's understood. Okay. Well, let's look at some problems in Plato now. I think you got it.